Okay, let's reiterate. S is the action. It is defined as the integral from 0 to capital T of the Lagrangian, this curly L, this function of Q, Q dot, and T. Our goal is to find the function Q of T that will maximize or minimize S. And we can construct Q of T to be a linear combination of Q star and epsilon for any real number K. If Q star is fixed and epsilon is fixed, then S is really just a function of K. If I'm going to assert that Q star is the optimal choice for Q, then S of K has to achieve its global maximum at K equals 0. If it didn't, if it achieved its global maximum or global minimum somewhere else, then Q star plus K epsilon T would be a much better choice for Q than just Q star by itself. So that can't be true. Now, if S of K is to achieve its global maximum at K equals 0, then it is necessary but not sufficient that ds dk at K equals 0 equals 0. How do we take this derivative? Well, we apply the multivariable chain rule. dl dk depends on two different pieces, dl dq, dq dk, and dl dq dot, dq dot dk. These latter two derivatives are just epsilon and epsilon dot respectively. So here we have it. This derivative has to equal 0 for any choice of epsilon of t. It becomes more obvious what Q star needs to satisfy when you apply integration by parts. You get a term which is not underneath the integration symbol, which is just the antiderivative of this multiplied by that, and you get a term that is underneath the integration symbol. The derivative of this times the antiderivative of that, and you keep the integration. So here you see the term here. And we can factor out the epsilon of t. So here is the thing to observe. If epsilon of t is allowed to be anything at all from 0, for t from 0 to capital T, and it's allowed to be anything at all at its start point and anything at all at its end point, then the only way that this thing here, which is the same as this, the only way that this could possibly equal a constant number, 0, is if this quantity here is equal to 0, and this quantity here is equal to 0, and this quantity here is equal to 0. If any of them were not equal to 0, then we could choose epsilon to violate the rule that this quantity has to equal 0. So, these are the conditions that Q must satisfy. This is called the Euler-Lagrange equation. This is called the start point and the end point condition.